Neanderthals ruled Ice Age Europe for 300,000 years. That's longer than our own species has even existed. They were fearless hunters, immensely strong, with a muscular build that let them take down bison and mammoths at close range. But then suddenly they vanished. And for over a century, scientists have debated why. Was it war with invading modern humans? A violent clash between two species competing for the same land and game? Scientists now trace clues from Italian volcanoes to Greenland ice cores, searching for a different answer. The story begins at Gibraltar, where a vast complex of caves once stood on dry land, far from today's encroaching sea. 24,000 years ago, at the height of the last ice age, sea levels were more than 100 feet lower than today. This exposed coastline became the very last Neanderthal stronghold on Earth, a final refuge. Gibraltar holds the densest concentration of Neanderthal sites anywhere on the planet. Dozens of caves packed into a few square miles. Good conditions, mild climate, abundant game, and sheltered caves let this population survive longer than any other Neanderthal group. Excavators here unearthed tools, animal bones, and the remains of a Neanderthal campfire preserved for tens of thousands of years. That campfire's charcoal was radiocarbon dated to roughly 47,000 years ago, a snapshot of Neanderthal life. By dissecting the charcoal under a microscope, researchers can identify the plants growing here 47,000 years ago. For generations, Neanderthal families likely gathered around this very fire, cooking venison and wild game. This warm family scene is a far cry from the brutish ape-man image pinned on Neanderthals when they were discovered in Germany in 1856. A curious bone from a scavenger bird, one that eats bones, shows clear-cut marks, but it wasn't butchered for meat. Instead, they harvested its striking feathers, large, dark plumes, probably to wear as personal adornment. Other artifacts hint that Neanderthals also used body paint and crafted simple jewelry, a vibrant personal display. Deeper inside the cave, researchers uncovered something even more remarkable, a deliberate rock engraving, a grid pattern carved into the stone, carbon dated to at least 39,000 years old. This grid may have served as a clan marker, a claim on the cave. This engraving challenges the old myth that Neanderthals lacked abstract thought. They were capable of symbolism just like us. The Neanderthal story begins 600,000 years ago in Africa with another species, Homo heidelbergensis, the evolutionary ancestor of both Neanderthals and modern humans. This shared ancestor was the first to control fire and hunt with wooden spears, a leap forward from earlier hominins. Some groups of heidelbergensis left Africa, spreading into the Middle East, Central Asia and Europe, the first step toward becoming Neanderthal. A slight wobble in Earth's axis tilted the North Pole further from the sun, triggering a dramatic ice age cooling. Across the northern hemisphere, average temperatures dropped by roughly 20 degrees. Around 300,000 years ago, a new breed of human emerged in Europe, Homo neanderthalensis. Their skin grew lighter, helping them absorb more sunlight during the shorter northern winter days. Their hair became straight and thick, a natural insulation against the bitter cold. A muscular, stocky build with short limbs and a barrel chest made them perfectly suited to the rugged Ice Age terrain. Neanderthals survived by living in tight, protective family clans where everyone looked out for each other. Because individual lives were often short, children depended heavily on the whole group for survival. These clans ranged across Europe, the Middle East, Central Asia, and even as far north as Siberia. With scarce plant life in the frigid climate, Neanderthals relied almost entirely on hunting for food. Their primary weapon, the thrusting spear, forced them to get dangerously close to massive prey like bison. Once the kill was made, Neanderthals used every part of the animal. Meat for food, hide for clothing, and bones for tools. 40,000 years ago, something shifted in Ice Age Europe. For 300 millennia, Neanderthals had been the sole masters of this land. But now, a new species was pushing into their territory, and nothing would ever be the same. Homo sapiens, our own direct ancestors, had emerged 200,000 years earlier on the savannas of Africa. For most of that time, they stayed put, but around 80 to 60,000 years ago, groups began heading north, following game into the Middle East and Asia. A few of those groups pushed west, crossing into Europe around 60,000 years ago. They carried something Neanderthals had never seen before, a different kind of weapon. These were throwing spears, lighter, more aerodynamic, designed to be hurled from a distance. A Neanderthal had to get within arm's reach of a bison to kill it. A modern human could drop the same animal from 20 paces away. Modern humans had evolved in Africa, where scattered water sources favoured the ability to cover huge distances quickly. They became endurance runners, lean, long-limbed, built to travel light and fast. Their technology reflected that, portable, lightweight, easy to carry. These newcomers weren't explorers passing through, they were hunters, and they came seeking the same land and the same game that Neanderthals had relied on for thousands of generations. The stage was set for a confrontation. Whenever human populations have come into contact throughout history, there's almost always been conflict. These guys are coming, they're trying to steal our land, we have to fight them. It's hard to believe Neanderthals and modern humans would have been any different. For over a century, many scientists have marked this as the beginning of the end. Within 10,000 years of modern humans' arrival, Neanderthals had disappeared across most of Europe. The timing seems more than coincidental. There's tantalizing physical evidence that supports this theory. A rib bone from a Neanderthal skeleton found in an Iraqi cave, dating to 40 to 50,000 years old, bears the mark of a fatal wound. This may be the best case of a Neanderthal murder victim ever found. The question is, who was the killer? Only two possibilities exist: another Neanderthal or an invading Homo sapiens. Forensic anthropologist John Hawkes examined the rib. The wound was made by a very small, sharp point, nothing like the heavy broad blades Neanderthals used. The angle of entry was downward, suggesting the weapon was thrown from above. That precision, a small sharp point hurled from a distance, is the signature of a modern human's throwing weapon, not a Neanderthal's heavy thrusting spear. This rib might be the oldest documented evidence of interspecies violence. This proves at least one violent encounter between the two species, and in this case, the Neanderthal lost. Yet Neanderthals were shorter than their Homo sapiens rivals, on average 4 to 5 inches, but because of greater muscle mass, they weighed the same. Their pectoral muscles measured roughly twice the size of the average modern humans, a clear sign of their extraordinary upper body strength. Researchers estimate Neanderthals could produce up to 90% more force than a modern human, enough to overpower almost any opponent in close combat. High natural androgen levels, sex hormones that build muscle and bone density, likely made Neanderthals more physically aggressive than modern humans. On their home turf, Neanderthals may often have won these confrontations. They knew the terrain and were accustomed to fighting at close quarters. Survival also meant enduring brutally cold Ice Age winters. So who was better built for extreme cold, the stocky Neanderthal or the tall, lean modern human? Researchers tested two body types, one stocky and muscular like a Neanderthal, the other tall and lean like a modern human, inside an extreme cryotherapy chamber set to minus 166 degrees Fahrenheit. The stockier, muscular body retained a higher skin temperature throughout the exposure and rewarmed far faster once out of the chamber. This build proves Neanderthal physiology was tailor-made for the cold. Their stocky frame, short limbs, and dense muscle mass were perfect thermal adaptations. So maybe intelligence, not strength, or cold tolerance explains modern humans' edge over their Neanderthal cousins. Since their discovery in Germany in 1856, Neanderthals have carried a brutish, dim-witted reputation, the classic caveman stereotype. For over a century, that heavy brow ridge was read as a stamp of low intelligence, a primitive forehead that supposedly housed a primitive mind. But in a lab in France, forensic anthropologist John Hawkes used 3D laser scanning to peer inside actual Neanderthal skulls and test that old assumption directly. What the scans revealed surprised everyone. The frontal lobes, the seat of planning, problem-solving and creativity, were almost identical in size to our own. But one area did differ. The occipital bun, a bony knob at the back of the Neanderthal skull, was significantly enlarged. That bump houses the occipital lobe, which processes vision, pattern recognition, depth perception, the visual cues a hunter needs to track prey at a distance. But the real proof of Neanderthal intellect lies not in their skull shapes, it's in the tools they left behind. To an untrained eye, Neanderthal knives look crude, especially next to the carefully chiseled blades modern humans crafted, which could take hours to shape. But Neanderthals didn't need hours. A skilled Neanderthal napper could produce a usable knife in just a couple of minutes. Fast, functional, and effective. A comparable modern human blade, on the other hand, could take an entire day to make, carefully pressure-flaked, retouched, and polished to perfection. But the Neanderthals' rapid-fire approach didn't sacrifice quality. Their stone flakes still carried edges that were both razor-sharp and remarkably durable. Modern researchers who tried to replicate the Neanderthal technique found it so demanding that it took a full year of practice to get right. The secret was geometry. Neanderthals struck the stone at an extremely precise angle, not a lucky blow, but a controlled, repeatable skill passed down for generations. A single flint nodule, carefully worked, could yield up to 70 razor-sharp flakes, an almost assembly line efficiency that kept Neanderthal toolkits constantly replenished. In a direct side-by-side test, the Neanderthal stone blade sliced through a tough hide with noticeably less effort than a modern metal knife. The edge was that sharp, that durable. But in at least one case, Neanderthal invention actually surpassed what modern humans had achieved at the time, a technological leap that left even scientists impressed. In 1963, a German mine yielded a small black, unremarkable-looking object, but it carried something extraordinary, the fingerprint of its Neanderthal maker, preserved for 50,000 years. Chemical tests revealed the substance did not occur anywhere in nature. It was a synthetic material, the oldest ever found, made by Neanderthals from birch bark. This Stone Age superglue, called pitch, bonded stone blades firmly to wooden shafts, creating a weapon that was both durable and deadly. A technological leap that gave Neanderthal spears real staying power. Making pitch required heating birch bark to roughly 750 degrees Fahrenheit, a precise temperature that would ignite the bark in open air, so Neanderthals had to find another way. In open air, the bark would ignite at much lower temperatures, so Neanderthals had to seal off the oxygen completely, a clever solution that required careful planning. To test this, researchers buried one container inside another, sealing them with mud, exactly as Neanderthals would have done, to recreate the process and see if it worked. The full process took only about 20 to 30 minutes, a quick, efficient method that produced a powerful adhesive showing Neanderthals had mastered a complex chemical process. This proved Neanderthals could invent complex processes, not just imitate, they understood cause and effect, distillation, and material science, long before modern humans arrived in Europe. So why did such capable, adaptable people, strong, smart, innovative, eventually disappear? The answer, it turns out, may have had nothing to do with their abilities at all. Maybe the hunting method itself explains the difference. Neanderthals closed in with heavy thrusting spears, while modern humans threw lighter projectiles from a distance. In Petaluma, California, weapons experts Mike Lodes and Scott Thomas tested both weapon types against a pig carcass target to compare their killing power. Even with a thrown spear, the hunter had to close to within 6 to 8 meters of the prey for a clean strike. No Olympic distance throws here. When the thrown spear struck the pig carcass, its stone head sheared off on impact, the blade detached, though the shaft still penetrated deep enough to kill. Still, the Neanderthal thrusting spear drove in visibly deeper on impact. The full force of the hunter's body behind the point punched through hide and muscle. To get precise measurements, Lodes took the weapons to the University of California, Berkeley, where ballistics gel tests would compare their destructive power under controlled conditions. An air cannon replicated each weapon's true striking force. The Neanderthal thrust at full strength, the modern human throw from a realistic hunting distance. The thrown spear lost roughly 30% of its force in flight. The air cannon showed it struck with significantly less energy than a thrust delivered at close range. The thrusting spear tore through the gel with dramatically more internal damage. The shockwave alone would have stopped the heart of any animal hit at that range. The thrusting spear proved a genuine Neanderthal strength. Their close-quarters hunting style was not a fatal weakness, but a brutally effective adaptation. Despite this, Neanderthals persisted long after modern humans arrived. They didn't vanish overnight, but held on for thousands of years in their Ice Age strongholds. So modern humans likely didn't simply hunt Neanderthals to extinction. The weapons test showed Neanderthals had the edge in close combat, and the archaeological timeline shows coexistence, not conquest. In Germany, a 60,000-year-old Neanderthal skeleton reveals another overlooked trait, one that challenges our assumptions about who they were. The body lay carefully arranged, one arm deliberately crossed over the chest, as if someone had posed it with intention before the burial. It was packed tightly in earth and sealed with a layer of protective clay, a deliberate effort to keep scavengers from disturbing the remains. This suggests deliberate burial, a behavior once thought uniquely human, now revealing that Neanderthals also honored their dead with ritual. Multiple Neanderthal sites now reveal varied, distinct burial traditions, some with bodies aligned, others with large stones placed over them, each as unique as human customs. In the mountains of Romania, in 2002, cavers stumbled on a mysterious jawbone, a discovery that would rewrite the story of Neanderthal and modern human relations. Reaching the site required swimming through a flooded underwater passage, a treacherous route that kept the cave pristine and undisturbed for millennia. Inside, a chamber called the Gallery of Bones, its floor covered with animal remains and scattered among them fragments of human fossils from 40,000 years ago. These fragments dated back roughly 40,000 years, remarkably well preserved, as if the cave had been waiting to share its secret with the right discoverers. Researchers spent 3 years painstakingly reconstructing a skull from 40 individual pieces, each fragment a clue to a face from the distant past. The completed skull showed an unusually long face and oversized teeth, features far from typical for modern humans, hinting at something else. It also carried an occipital bun, a distinct bump at the back of the skull, a trait that is unmistakably Neanderthal. Deep in a Romanian cave, scientists unearthed a skull that defied easy classification, a modern human with unmistakable Neanderthal features. For paleontologist Silviu Constantin, who spent 3 years piecing those 40 fragments back together, this was the missing link, the physical proof that the two species had once met and mingled. The skull's long face, oversized teeth, and that protruding occipital bun, all Neanderthal, on a body that was otherwise fully modern Homo sapiens, it pointed to one thing: interbreeding. This discovery sent scientists on a new hunt, not for bones in caves, but for traces of Neanderthal hidden inside our own cells. In 2010, a team at the Max Planck Institute achieved the impossible. They fully mapped the Neanderthal genome from ancient bone fragments, giving us the first complete genetic blueprint of our lost cousins. When they compared that ancient genome to the DNA of living people, the result was staggering. Nearly everyone outside of Africa carries about 2% Neanderthal DNA. But that 2% vanishes once you cross into sub-Saharan Africa. People with deep African ancestry show essentially 0% Neanderthal DNA. This interbreeding likely happened around 60,000 years ago when modern humans first pushed out of Africa and met Neanderthals in the Middle East. In 2014, a team at the University of Washington took this further. They compared DNA recovered from Neanderthal bones to the genomes of more than 700 living people. The 2% you inherited from Neanderthals is different from the 2% I inherited. We each carry a unique slice of that ancient genome. Add up all those different slices across the global population, and about 30% of the entire Neanderthal genome is still present in people alive today. Many of those inherited genes affect hair and skin, fair skin among Europeans for instance, and straight hair, both likely Neanderthal gifts that helped our ancestors adapt to colder, darker northern climates. Fair skin, a trait common among Europeans, maybe a Neanderthal inheritance, helping our ancestors absorb more sunlight in northern latitudes. Other inherited genes influence fat storage, a trait that helped Neanderthals survive harsh winters, but may now contribute to modern obesity. These traits likely helped early modern humans adapt to new climates as they spread out of Africa, giving them a survival edge in colder regions. But if these genes were so beneficial, why did the Neanderthals themselves vanish? One clue is population size. Neanderthals likely never numbered more than around 100,000 people across their entire range. Such a small, scattered population was highly vulnerable to regional disasters. A bad winter, a drought, or a volcanic eruption could wipe out entire clans. German lake sediment cores reveal a detailed ancient climate record, with each thin layer capturing a single year of environmental change. These cores show climate shifting drastically within as little as 10 years, turning landscapes from forest to frozen steppe almost overnight. Neanderthal forests were rapidly turning into barren, frozen steppe, shrinking their hunting grounds and reducing prey populations. Their population possibly collapsed to as few as 20,000 individuals, pushing the species toward a precarious tipping point. A small, scattered population was vulnerable to sudden catastrophic events. A volcanic eruption could wipe out entire regions in days. History shows volcanic eruptions have repeatedly devastated human civilizations. Tambora in 1815 caused a year without summer and mass starvation worldwide. In April 1815, Mount Tambora erupted with such force that it ejected ash and gas high into the atmosphere, circling the Earth and dimming the sun. The following year became known as the Year Without a Summer, as crops failed and livestock died off across the globe. But Tambora was dwarfed by the Toba supervolcano in Indonesia, which erupted around 74,000 years ago. It produced a mushroom cloud of sulfuric acid and gas 100 times larger than Tambora's blast, spreading ash across Asia, the Arabian Peninsula, and even into Africa. To understand the true scale of ancient eruptions, scientists turn to the Greenland ice sheet. This frozen vault, built from snow that never melted, preserves a yearly record of the planet's atmosphere going back over 100,000 years. At a research station atop the ice, geologist Jim White drills down to extract a core from the layer dating to roughly 39,000 years ago, the very time the Neanderthals were vanishing across Europe. Back in the lab, the ice core is melted layer by layer. The analysis reveals a sharp spike in sulfate, a clear chemical fingerprint of a massive volcanic eruption that occurred exactly when Neanderthal populations were at their most vulnerable. The likely culprit was Campiflegrae, a supervolcano in southern Italy. Its caldera is 8 miles wide, most of it hidden beneath the Mediterranean Sea, and it is Europe's largest and most dangerous volcanic site. Scientists carbon-dated ash deposits from Campiflegrae and found they matched the 39,000-year mark, the exact age of the sulfate spike in the Greenland ice core. But the eruption's true scale only became clear when geologists found ash from the same blast across Romania, Russia, and as far south as Libya. Chemical analysis confirmed every sample carried an identical fingerprint, a single continent-spanning cataclysm. Using a computer simulation, volcanologists reconstructed the event. The eruption of Campiflegrae raged for between 2 and 4 days, ejecting a column of ash and gas that rose over 20 miles into the stratosphere. Pyroclastic flows, avalanches of superheated gas and rock, burst from the volcano at speeds approaching 500 miles per hour, incinerating everything in a 40-mile radius. The ash clouds spread across 3 continents, blocking out the sun for weeks. The world plunged into a volcanic winter, with temperatures dropping sharply as the sun's light was diffused by the lingering debris. Even a thin layer of ash poisoned the soil with fluorine, killing the small plants that animals and Neanderthals depended on. The first to die were the children and the elderly, but soon starvation and fluorine poisoning claimed nearly everyone. Only the Neanderthals in Gibraltar, far from the ash, survived another 15,000 years, living on as they always had. Today, the ground at Campiflegrae is still rising, and volcanologists monitor it continuously, knowing it could erupt again. Yellowstone, an even larger supervolcano in the United States, is also considered overdue to erupt, a sleeping giant beneath a national park. A super eruption today could devastate agriculture across an entire continent, triggering global food shortages and mass starvation. Modern humans survived because our species had spread across the whole globe, making us more resilient to a single catastrophe. Neanderthals live on today, inside the DNA of billions of us, a permanent legacy from our closest human relatives.